All right, so this is how to find the inverse of a matrix. So we're given a matrix M here. And so it says, inverse is going to be M inverse if it exists. Remember, it could be singular. It doesn't have to actually exist. Has the property that M times inverse is equal to I. So M times, this is going to be our M inverse is equal to I. So again, I'm saying this is going to be what our M inverse is. And so what we can do is we can multiply out and get our left side and get, the first row times the first column, second row times the second column, and so on. And we can do that for each of the columns and get all three of those. And notice on the first one, we get the first column, then we get the second column, and then we get the third column. And if we combine all this together, what we get is, this is what it looks like if we put it into augmented matrix format. And putting it all together in one format, we get this. So basically, we get our M times the identity, and that's going to be M identity, and that's augmented. What we're going to do then is we're going to try to go and make this over here the identity, and then what happens is whatever is over here then is going to be M inverse. Okay, so now what we have to do is we have to work our way down to make this look like this. So this is going to actually end up being over here. So we're just going to do row operations and stuff like that. And so what's going to happen again is we're going to get I, and it's going to be times B, and that B is going to be our inverse. Okay. All right. So first things first, what are we going to do? Well, we need to make that a one, which we did. Now that's a zero. Now we need to make that a zero. So multiply -2 times that row, add it to that row, and we have this row now. Then we need to make this a one. So we're going to take half of this row, and that's going to change what the middle row is. And so we get this. Now we need to make this a zero, so we take a -5 times that plus that, and when we do that, we get the following. Now we need that to be a one because again, we want ones down the diagonal and zeros everywhere else. So if we multiply this times two, that'll make that a one. Now we want everything above to be zero. So this one luckily is already zero. So all we have to worry about is this here column. So we'll take a half times this row plus that row, and a -1/2 times this row plus that row, which is represented here, and we get this. And so what we now have is this is going to be B is what they call it, or it's also called the inverse, M inverse. Okay. And so that gives, our A, B, C, D, E, F, G, H, I that we had before. Because if we go all the way back, where was that? We had this is what we were looking for. That was our M inverse, we said. And so where did I go? Too far? No, not far enough. So that is our M inverse. Okay. Now, one thing to note is if we take M inverse times M, multiply those two together, 3 times 1 is 3, that's 0, and that's -2. That gives us a 1 up in the top left. Then we have 3 times that's going to be a -3 plus 6 minus 3. And so that's going to give us a 0. And we keep going. What's going to happen is if we multiply those together, and they're going to cheat here, they're going to show you how to do it on the calculator, we end up with the identity matrix. But we could also do it just by hand, going through all the different things. And what we end up with is our identity matrix, which is what we should get if we take the inverse times the regular matrix. Okay. And so thus M inverse is times M is equal to I. And so then we did therefore find the correct inverse of the matrix when we did our row operations. All right, so if M augmented with I is transformed by row operations into I, then augmented with B, then the resulting matrix B is really M inverse. However, if we obtain all zeros in one row or more rows to the left of the vertical, then it doesn't exist. So, if we have something like the following, if we had when we got to a certain point, we had, 1, 0, 0, 0, 1, 0, and 0, 0, 0. And no matter what we had over here, this means we don't have inverse because we have to have a 1 here, and then whatever over here comes out, that's going to be our inverse. But if we end up with a row of zeros, then we don't have an inverse, and so we just say no inverse. Okay. All right, let's stop there and we'll come back for some more.